This chapter talks about averages and means, and it says that the mean is the most common average, the one that you have doubtlessly calculated many times. And to find the mean or the average, you add all the scores together and then divide by the number of scores. So they describe two different types of means. There's the population mean and the sample mean. The population mean describes a complete set of scores, and the sample mean describes a subset of scores. So when doing a study, the sample is just part of the population, and the data can be applied to the population, and we're just dealing with the averages or the means of those sets of data. So the sample mean is the balance point for a sample found by dividing the sum for all values of all scores in the sample by the number of scores in the sample. So that is represented by X bar, which is just an X with a bar over the top of it. And part of the sample population, or the sample size, or part of the sample mean is the sample size, which is represented by just a small n, which is the total number of scores in the sample. So basically this formula right there for sample mean is x bar equals the sum of the variable x divided by the sample size n. And the Greek letter sigma is the symbol for the sum of. And then there's the population mean, which is the average for the population that you're studying. And it's defined as the balance point for a population found by dividing the sum for all scores in the population by the number of scores in the population. And this is designated by the Greek symbol mu. And the population size is the total number of scores in the population. So that's basically the same thing as the sample size, but at a larger scale, and it's designated by a capital N rather than a lowercase n. And the formula for this is the same formula for the sample mean, but the symbols are changed to fit those that are associated with population rather than sample. So it would be mu equals the sum of variable x divided by the population size n. And they just give an example of recent presidents. And then it talks about the mean as a balance point, which basically means that the mean serves as a balance point for its frequency distribution, which is basically that the sum of all scores expressed as positive and negative deviations from the mean always equals 0. So if the data isn't skewed and the mean equals the median and also the mode, then it would serve as a point of equilibrium. So all the scores above the mean counterbalance those below the mean. So the mean reflects the values of all scores, not just those that are middle ranked, which is what the median measures, and not just those that occur most frequently, which is what the mode measures. And then we move on to section 3.4, which average. And it just talks about skewed distributions and like how you should go about explaining averages with that. So if a distribution of scores is not too skewed, then the values of the mode, median, and mean should be similar, and then any of them can be used to describe the central tendency of the distribution. But that's not always the case if the scores are skewed. So the mode is the one that's or the mean is the one that's most highly sensitive to extreme scores and outliers, but the mode and medium are largely unaffected. So when a distribution is skewed, it's best to report both the mean and the median as well. If the mean exceeds the median, then the underlying distribution is positively skewed because one or more scores have a large value, and then it's the same for median but opposite. So if the median exceeds the mean, the underlying distribution is negatively skewed because of one or more scores with small values. And here are just some samples of visual of a positively skewed distribution and negatively skewed. So the tail end of the graph is towards the positive end for a positively skewed distribution, and the tail end is towards the negative side for a negatively skewed distribution.